Hello, my name is Ahmed Mohammed, and I would like to introduce my project. And it was related to machine-to-machine system. And I think the best way to start my project is to explain what the meaning of the OSI models. Let's do it. The OSI layer has 7 layers. The first layer is related to everything physical, such as cables. The data link related to the MAC address. So within the same line, two PC are connected to each other using this physical address. The third layer, network layer, this is the internet actually, the IP, how the packet is moving from one LAN to another LANs. The fourth layer is transport layer. This is responsible about end-to-end communication and provide reliable connection between PCs. The 5th layer and 6, this is where machine-to-machine system work. The 5th layer is responsible about establish and ending the session between PCs, and the 6th layer is presentation. This is where encrypted and decrypted data. So these 2 layers, session and presentation, they are responsible for building the framework of the machine-to-machine system. And provide API to the connected computers. Lastly, the application. This is where our application is working. Now, the structure of the system. The structure of the system is consisted from 4 IoT devices. The first one is the server, Raspberry device. This is where administrator can see all the connected sensor and actuator from on this PC. This is temperature sensor, and this is gas sensor is connected to Android device, and the temperature sensor connected to Raspberry device, and we have one actuator connected to the Raspberry device, and all of the data measured by the sensor will be sent using the machine-to-machine to the central machine. Let's move to see the central machine or the server. This is the server of the system. It's connected to all the others machine. This is the machine. It's connected to the DC motor, which needed a driver board in order to control or move the DC motor. This is this is a gas sensor. It's connected to Android device, and this is the temperature sensor. It's waterproof sensor. It's connected to the Raspberry device. Now, let's move to the server. This is the server. So all the data it will be shown on the screen of the server. This is the gas. This is the time x-axis and y-axis. This is the concentration of the gas for LPG, and this is the temperature sensor. This is the time axis, and this is the temperature. Okay, let's do some interaction between the sensor and actuator. Okay, if we increase the concentration of the gases by using a lighter, press the lighter slightly and see what is how the change. We can watch at the same time the motor. If we do any practical test between the actuator, the DC motor, and the sensor, when the concentration of the gas above 1000, if we see at the same time to the screen, if it's above 1000, the motor will be stopped. And when I release my hand, it will keep working. Let's do it again in order to clarify this point. If I push the gas and at the same time look at a screen, when the gas above 1000, the motor will be stopped. And when I release my hand, it will be working. If we see on the screen, the first line is the for time. Every 1 second, the values will be changing. The others 4 column for is responsible about concentration for the gases, for LPG, CH4, CO, and the last line is responsible about the ratio, the concentration between RS and over R naught. This is the concentration of the gas and the temperature reading. It will be moved by using the machine-to-machine communication to the central machine, where it will be shown using a Johnny plot utility. The Johnny plot utility is take the data from the central machine without concerning to the way how this information is gathered on the central machine. Let's do a test. If we increase the temperature by heating up the sensor and see at the same time to the temperature to the plot, we can see it's changing. We can see it's changing, and if we release it, it will be returned to the normal temperature. Okay, the same thing for the gas. When I apply the gas, it will be changing here. And the same thing on the screen on the center machine. So this is my project, and I would like to thank Dr. Alex, who is my supervisor, for helping me to do this project. Thank you very much.